All right, let's talk about some basic probability definitions. And now you're wondering, what does this picture of a beautiful beach have to do with basic probability definitions? And the answer is absolutely nothing. But because this video is about definitions, I wanted it to at least start off looking really nice because the rest is super boring. So let's get into some key terms. First, we have an experiment. An experiment is simply something that is planned, right? A planned operation that we carried out. The key is controlled conditions. You have all of the variables under control, and then you are planning something, right? The purpose of an experiment is to see how it comes out based on the controlled factors that you are in charge of. And then we have a trial. A trial is simply one repetition of an experiment, right? Because a lot of times we will do an experiment multiple times to see, do we have the same outcomes? Well, a trial is one piece of that. And then the outcome, as I've already used that word, it's any possible result of an experiment. So when we do a trial, one repetition of the experiment, we get an outcome, and then we repeat this to see whether or not we have, like, can we make any conjectures? Can we say, hey, when we do this, this other thing happens? That is the purpose of an experiment. So Billy flips a fair coin. These are some very basic examples because I am a basic human. So Billy flips a fair coin. Identify the experiment, the trial, and the outcome. Okay, so the experiment by itself is the flipping of the coin. Now, we might do this 80 times, 20,000 times, 4 times. Who cares? The experiment is just the act of flipping this coin. The trial is simply one flip of the coin, right? And this kind of makes sense. So if the experiment is, hey, we want to see what happens when we flip a coin, a bunch of times. So we do it one time, and then we have an outcome. The outcome is either going to be heads or tails, because remember, we are flipping a fair coin. And it's simply the result of the flip. So you perform a trial, one flip of the coin. You get an outcome, either a heads or a tails. You record that, and then you continue to repeat this, thus the entire experiment. It's very exciting. Okay, that's the first set of terms. Now let's go to set of terms number 2. And there's only 2. This is the end. So first we have the sample space. So the sample space is all possible outcomes of an experiment. So thinking back to our fair coin flip, the sample space would have been heads or tails, right? Because that's the only possible outcomes you could have. An event is a subset of the sample space. Probability, a measure of a particular event happening compared to all events happening in a sample space, right? I like to just say probability is what we want to happen over all possible chances or choices. We'll show that in a second. And then likelihood. Likelihood is basically just interpreting the probability. So you find the probability and then you say, based off that answer, how likely do you think it is to happen? So let's look at an example. A 6-sided die, let's consider this a fair die, right? Not weighted in any way, shape, or form, is tossed one time. Discuss the sample space, the event, the probability of tossing a 1, and the likelihood of that toss happening. So think of the sample space with a 6-sided die. If you look at it, there are dots numbered basically 1 through 6. So the sample space is the set of all possible outcomes. 1, 2, 3, 4, 5, 6. I can count like a beast, right? We have 6 total possible outcomes here. That is our sample space, all of those possibilities. Now, the event is a subset of that. So maybe we could say, tossing an even number. That would be an event. That is a subset of the sample space. Like a 2, 4, and a 6 would be even, or it could be odd numbers. There are a lot of different events we could have with this. Okay, the probability of tossing a 1. If you think about this, before I just throw this up here, we have 6 possible outcomes. That means in our probability, the denominator is going to be 6 because the set of all outcomes is the denominator in probability, and the numerator is what we're talking about. So if we're tossing a 1 on a 6-sided dice, there is only one way to toss a 1. So one option out of 6 total outcomes gives me a probability of 1 out of 6. Now, when we move on to talk about likelihood, 1/6, we're talking like 16-ish%. That's pretty low. So the likelihood of me just tossing a 1, I would say it's not very likely. It's only got about a 16% chance of happening. However, a 2 out of 2, rolling a 2 or tossing a 2, tossing a 3, every die, if we're talking about a fair die, has the same likelihood, the same probability of being tossed. And therefore, even though tossing a 1 isn't very likely, it is just as likely as any other given number on that die. So let that sink in, a little bit of fun. Probability and likelihood are not the same. Likelihood is the interpretation of the probability. All right, thanks all.